In this tutorial, we're going to learn how to apply a non-compensatory approach to informing selection decisions using what's called the Angoff method. So to begin, you'll see that we have RStudio open, and then we also have two .csv files that we're going to be working with today. So these are comma-separated value files here. And so the first one is called Angoff_SME. As you can see here, I've saved it into this folder here, which I'll subsequently set as my working directory. So for me, my working directory is my H drive, our workshop folder. The second file is called Angoff_applicant. We're also going to save that to a folder that we can set as our working directory. So assuming that we have those files ready to go and saved into a folder that we can subsequently set as our working directory, we can go ahead and get started. All right, so opening up RStudio here, we see the typical background information here because this is a new session, and specifically it's indicating what version of R that RStudio is running on top of. I'm going to clear that out right there, and I am going to now go to File, New File, and RScript to open up a new RScript editor window. And the first thing that I'm going to do in this RScript editor window is use the annotation feature, and I'm just going to give a name to this tutorial here. And so I'm going to call it the non-compensatory approach to selection decisions using Angoff method. Now, next thing that we're going to do is we need to set our working directory. And that's going to be the folder where we saved our two data files that we're going to be working with here today. So I'm going to use the setwd function here, and in the function parentheses, I'm going to type in quotation marks, and I happen to remember the exact path for that folder where I saved those files. It's my H drive, our workshop folder. So I will go ahead and run that line there. The next thing I will mention is that if you wanted to select another folder and you don't remember the path off the top of your head, you can go to Session, Set Working Directory, Choose Directory to find the folder where your files are saved. Okay, so now that we've set our working directory, R knows where to look for those two data files. And we're going to read in the first one initially, and then later on we'll read in the second one where it makes sense. So I'm going to make a little note here that step one in the Angoff method that we're going to be applying is that the SMEs, so the subject matter experts, are going to estimate the probability that a minimally qualified applicant would provide correct response to an item from a selection tool. Okay, so the Angoff method is going to make sense when we have a multiple choice style selection tool where there's a correct response and incorrect responses. Okay, so to do that, we're going to assume that the SMEs already estimated those probabilities for each one of the items of the selection tools we're going to be looking at. And so we're going to assume that the data file that I was mentioning before, I showed at the beginning, Angoff_SME, has that data from those SMEs. So we're going to read in the data file containing the SME probability estimates. Okay, and to do so, we're going to use the read.csv function, which comes from base R. You could just as easily use the read_csv function that comes from the reader package. And we're going to name this data frame object that will assign the data frame that we read into. We'll call this df1. We'll use the left-handed arrow assignment operator. Alternatively, you could use the equal sign operator. And then the name of that function is read.csv. It comes from base R, so we don't need to install a specific package for that. Within the function parentheses, let's type in our quotation marks. And I happen to remember the exact name of the file because I did not change it when I saved it to my working directory. It's Angoff, A-N-G-O-F-F, all lowercase, _SME, all lowercase, and make sure you include that .csv extension. So let's go ahead and run that line there, and you should now see that we have a data frame object called df1 with 5 observations, so that's 5 rows of data, and 9 variables, that's 9 columns. So let's take a look and see what we have here. So the first column is a unique identifier for our subject matter experts or SMEs, so it ranges from 1 to 5. So each row of data represents the estimated probabilities given by one of the SMEs. And so the first 5 items here are from a cognitive ability selection tool test, and those are abbreviated as cog_ab_I and then the item number. The second 3 items are from a knowledge test selection tool, and we just have 3 items for that one. Each one of these values represents a probability. And again, these probabilities are from the subject matter experts where they're estimating the probability that a minimally qualified applicant could respond correctly to a particular item. Okay, so you'll see the probability for the first item is 0.78 from this subject matter expert number 1, and then you can see their estimated probabilities all the way down here. And remember, with a probability, the highest possible probability is going to be a 1, the lowest is going to be a 0. A 0.5 would essentially mean there's a 50-50 shot that someone gets it right. All right, so we're going to start with the cognitive ability test here in just a second, and then we will move on to the knowledge test when it comes to creating what are called cutoff scores, which is an important part of the Angoff method. Okay, so the next thing we're going to do is we are going to make a note that we're moving on to step 2 of this process. Actually, let's call this step 2 and 3 because essentially we're combining 2 processes here in this tutorial. And so we're to create the cutoff scores, which again is central for the Angoff method because this is a non-compensatory approach to selection decisions. And I'll also note that cutoff scores are sometimes referred to as cut scores or critical scores in this context. So to create cutoff scores, we're going to first compute the mean item probabilities. After that, we are going to compute the sum of those mean item probabilities. And that's going to give us our cutoff score or cut score for each of these 2 selection tools. So the first selection tool, again, being that cognitive ability test, the second one being that knowledge test. So let's start with that cognitive ability test, which again is a selection tool. And so the first thing we're going to do is we're going to compute the mean probability estimate for each item. And I'll make a note here that each item represents a column or variable in our data frame. So again, each item represents a column or variable here. So we're going to be computing the column means here to figure out, for example, what is the average or mean estimated probability for the first cognitive ability item across those 5 SME probability ratings. Okay, so to do this, we are going to use the call means function, which comes from base R, meaning we don't need a special package to use this function. And within the function parentheses, we're going to use matrix notation. So the first thing we're going to specify is the name of our data frame object, which is df1, which is what we read in here. And then we'll do square brackets. And then because we're focusing on column means and we're going to be estimating, we're going to be looking at the columns, we are going to put a comma. And then anything we specify to the right of that comma is going to be a column that we're referencing. If we had done this to the left, it would have been a row that we were referencing. And so to the left of that comma, we're going to do the C function. And within the C function, which is our combine function, we can combine elements into a vector, we are going to specify the names of these items here. Okay, so the cognitive ability 5 items. And so I'm going to go down here into my console and just use the names function with the name of the data frame, df1, as the sole parenthetical argument. I'm going to use that so I can get the exact names, so I can just copy and paste these in and I don't make any spelling errors. So first item, I'm going to type quotation marks. I'm going to copy that first cognitive ability item, paste it in. Outside the quotation marks, add a comma, quotation marks, copy the second item, paste it in, comma, quotation marks, copy the third item, paste it in, comma, quotation marks, copy that fourth item, paste it in, comma, quotation marks, and then lastly, copy that fifth item in here. Okay, so if we were to run this just by itself, which I'll do here to demonstrate, it's going to give us those column means for each one of these variables we've listed here, or each one of these columns, okay? And so you'll see here, the column mean for the first cognitibility item is 0.79. So if you just average these values here, you'll get 0.79. That's what's happening behind the scenes. Let's go ahead and assign this using an assignment operator like the left-handed arrow here. Let's assign this to an object that we can subsequently reference that we'll call cog_ab with a capital C and a capital A underscore item means with a capital I and a capital M. Okay, so let's rerun this line and assign it to that new object. And so now you'll see that object appears here in our global environment, and we'll see that vector of means listed there. Okay, so the second thing we're going to do is we are going to create a cutoff score, which is really the crux of the Angoff method, by computing the sum of the mean, the item means. Okay, so we're just going to take the sum of this object here, which is a vector, and that's going to give us a cutoff score, okay, for our selection tool. All right, so in order to do that, we're just going to use the sum function, which is from base R, and as our sole parenthetical argument, we're going to copy in to the function parentheses the name of that object. And if we were to run this just as it is, you'll get the cut score down here, which is 3.134. But let's go ahead and assign this using an assignment operator like the left-handed arrow assignment operator to an object that we'll call cog_ab, so cognitive ability underscore, and then we'll call this cutoff. Okay, so cog_ab with a capital C, a capital A, underscore cutoff, all lowercase. Let's assign. And so you should see now we've assigned to an object here, so we can subsequently reference it, our cognitive ability cutoff score. Okay, so the next thing that we're going to do is we're going to do that same thing for the knowledge test, that other selection tool. So I'm going to copy everything from my line 15 down to 21 here. And I'm going to paste it below so that I can just adapt this. So the first thing that I'm going to adapt is we're going to call this the knowledge test. The second thing that I'm going to adapt is I'm going to update the name of this object that we previously called cog_ab for cognitive ability item means. And we're going to call this no test, as in knowledge test with a capital K and a capital T. And then we're going to replace these items here. So we had 5 items for the cognitive ability test. We only have 3, as you can see, for the knowledge test. So we're going to delete these last 2. And then we're going to come down here, copy the first item for the knowledge test, paste it into the first set of quotation marks. We're going to do the same thing, copy the second knowledge test item, paste that in, copy the third knowledge test item, and paste that in. And so now we can run this line here to get the knowledge test, that vector of item means. So it's the estimated probability means. So if we click run, we get that. And you'll see over here, we get that vector. You can see that behind the scenes here of the 3 probabilities that correspond to those 3 items. Okay, so the next thing that we're going to do is we're going to come down here to this line that says cog_ab underscore cutoff, and we're going to update it so it's no test for knowledge test, KNOWTEST with a capital K and a capital T, underscore cutoff. And then we're going to replace within the sum bracket or parentheses here, the name. We're going to copy here the name of those item means object for that knowledge test, which is no test underscore item means here. We're going to copy that and then paste it here within the function parentheses of that sum function. We're going to click run. And so now we have our cutoff score or cut score for our knowledge test, and it's 2.19. Okay? So the next thing that we're going to do is we are going to make a note here, and we're going to move into step 4, which is we are going to acquire applicant scores on the 2 selection tools. Okay, so let's imagine that a set of applicants, we run them through these 2 selection tools here, and now we have their scores or their data on these selection tools. So whether they responded correctly or incorrectly to each one of those items. So if you remember, that other CSV file I referenced at the beginning was called Angoff _applicant.csv. We are going to read in the data file containing the applicant scores on the selection tools. And so we're going to do the same thing we did above. Let's call this object df2 for the second data frame. We'll use the left-handed arrow assignment operator. We use that same read.csv function from base R. And within the function parentheses, we're going to type in the exact name of that file that's located in our working directory that we set at the beginning of this tutorial. It's Angoff, A-N-G-O-F-F, _ applicant.csv. Don't forget that .csv within the function, within the quotation marks that are within the function parentheses. So let's go ahead and run that line to read in that second data frame, and let's take a look at it by clicking at that object, on that object in our global environment here. Okay, so here we have, as you can see, 20 applicants. They each have a unique identifier here, a unique ID, and then we see those same variables as before. So we have our 5-item cognitive ability test, and we have our 3-item knowledge test. Both of these are selection tools, and we'll see here that a 0 represents an incorrect response to a particular item from an applicant, and a 1 represents a correct response. Okay, so for applicant AA1, they responded incorrectly to the first 2 items because they received scores of 0. They responded correctly to the 3rd item, and then incorrectly to the 4th and the 5th cognitive ability items there. So you can see that first applicant for the cognitive ability selection tool here, they got a score of 1 out of 5 possible because they only got 1 correct. Okay? All right, so what we're going to do next here is we are going to make a note, and we are going to specifically, step 5 is going to involve applying the cutoff scores to applicant scores on the selection tools. Okay? And so the first thing that we're going to do is we're going to work with that cognitive abilities test here. So that's our first selection tool. And then we're going to compute the sum of the selection tool scores for each applicant. Okay? So we're essentially going to go through and just add up by computing the row sums each applicant's scores on the 5-item cognitive ability test here. Okay? So we're going to add, for the first applicant, we'll add up their scores on this 5 items, and they'll get a score of 1 because they only had 1 correct. All right, so to do that, we are going to use the row sums function from base R, so we don't need a special package or to install a package and access a package to access this function. It comes standard with R. Then we'll add the function parentheses, the name of the data frame object, which is df2, which is our second data frame object that has the applicant scores on these selection tools. And then we're going to add our brackets, our square brackets, and then comma, because we're going to be referencing columns instead of rows. If we wanted to reference rows, we'd put our information, our argument to the left of the comma, but because we're referencing columns, that goes to the right of the comma. Our C function, to combine elements into a vector, add the C function parentheses, and then we're going to list the 5 item names associated with that cognitive ability test. So again, I'm going to use the names function down in my console here. I'm going to type in the name of that second data frame, which is df2, hit return or enter, and I'm just going to copy and paste in these 5 items with quotation marks around them. Okay, so make a vector rather of these names. So the first item, copied that in and pasted that in. Second item, pasting that in. Note how they're all wrapped in quotation marks here. Copying in and pasting the third item, adding quotation marks, doing the same thing for the 4th item. And then lastly, copying and pasting in that 5th item. Now, before the last parenthesis here, I'm going to do something a little bit different than what we did with the row means function or the call means function above here. and that we used up here, and that is I'm going to add this argument, which is comma na.rm equals true. Because we're presuming that these data are coming from actual applicants, they're not really, I simulated these, but imagine they're coming from real applicants. It's very possible that applicants might skip items or something like that, so there could be missing values. So we're going to add this last argument, the second argument, that is na.rm equals true, which says remove the missing values that are represented by nas in R, and we're setting that to true. Okay, so watch what happens if we run this line as is. You'll see that we get the row sums for each of those 20 applicants here, okay? But let's go a step further and add this as a new variable to our existing data frame, the second data frame, which is df2, that has the applicant scores. And so to do that, we're going to use the left-handed arrow assignment operator. And then we're going to type in the name of our data frame object, which is df2, the second one, $sign. So then we can specify the name of our new variable. Let's call this cog_ab_sum. Okay, so for the cognitive ability sum for each applicant here. And then we're going to rerun this line here. And let's take a peek at our data frame object again, scroll over to the right, and you'll see that we have a new column or variable here. And so for the first applicant, AA1, as we talked about before, they have a score of 1 on the cognitive ability test. That's the sum of their correct response, incorrect and correct responses there. Where again, a 1 is a correct response, a 0 is an incorrect response. The second person, AA2, that second applicant got a score of 4, et cetera, all the way down to the bottom. Doesn't look like anybody got a perfect, or looks like one person got maybe a perfect score there. All right, so we've done that now for the cognitive ability test. And so the next thing that we're going to do is we're going to create a variable containing the selection tool pass-fail scores, okay? So we're going to create a new variable, a new column in our data frame that's going to contain whether or not someone passed or failed the selection tool. And this is where we're going to apply that cutoff score that we computed earlier. Okay, so the first thing that we're going to do is we are going to use what's called the if-else function. And this comes from base R, so we don't need a special package to install for this to use it. And then the first argument is going to be a logical statement or expression. And so we're going to specify the name of our data frame object, which is df2, $sign, and then the name of this new variable we created, that cog_ab_sum, which is the sum of the cognitive ability scores for each applicant on their selection tool. And so we're going to add that in here. Okay, so cog_ab_sum. And then the logical expression is going to be this: if it is greater than or equal to, so this is the operator for greater than or equal to here. It's greater than sign, equal to sign. It's greater than equal to our cog ability cutoff score. So you can see it auto completes here. This is that object we created earlier, cog_ab_cutoff. Okay, so if this logical condition is met, if it's true, we're going to say, comma, the second argument is what happens is it's true. And so we're going to create a new character value called pass, and because it's character, we're going to put it in quotation marks. Now, if this logical statement here in the first argument is false, this is where the else comes in from the if-else function. If that happens, we're going to say that that person gets a character score of fail here. And so we're putting that in quotation marks as well. So again, with the if-else function, the first argument is going to be some logical statement here that can either be true or false. So in this case, it's if the sum of their scores for the cognitive ability test is greater than or equal to the cutoff score that we set, which was 3.134, then they will pass, which is the second argument. If not, if that's false, meaning their cutoff score is less than, or rather the sum of their cognitive ability scores is less than the cutoff, then they will fail. So watch what happens if we run this as is. You'll see we get a vector for the applicants. These are the 20 applicants, and it lists whether they passed or they failed. Let's add this as a new variable by using that left-handed arrow assignment operator. And let's add it to that second data frame, df2 $, and we're going to call this new variable cog_ab_pass. So we're creating a new variable here. This is going to be whether they pass or they fail. Okay. So let's go ahead and run this. And then let's take a peek at our data frame again. And now we should see that we have a new column here, a new variable, and this is whether someone passes or fails. So you can see here with this second applicant here in the second row here, they pass because their sum of the cognitive ability scores was 4, which is greater than that cutoff score that we set of 3.134. Okay. And then you see the person before them failed because they had a score of 1, third person failed, et cetera, et cetera. So it looks like there was a lot of fails here and maybe only a few passes. Okay, so the next thing that we're going to do is we're going to do the same thing for the knowledge test. So let's copy everything from my line 38 to 44 so that we can then paste it below and adapt it for the knowledge test. So I'm going to replace cognitive ability test with knowledge test here in this annotation. And then as we did before, there's only 3 items in the knowledge test. So I'm going to adapt our row sums here to reflect that. And so I'm going to come down here and copy and paste in the exact names of those knowledge test items. So the first knowledge test item copied in, second one copied and pasted in, third one copy and pasted in. And then we also need to come over here and we need to update the name of this variable. We're going to call this no_test_sum for KNOWTEST. Okay. And then we're going to highlight that row and click run. Take a look at that data frame again, go all the way to the right, and you'll see now we have the sum for each applicant on their knowledge test. Okay, so here you can see for the first applicant in this first row here, they only got 1 correct, so they have a sum of 1 here. So that's their overall score. So we're going to do the same thing now, or what we did before with the cognitive ability test. We're going to create a variable containing the selection tool pass-fail scores. And so let's update the code here below. So instead of adding a variable called cog_ab_pass, we're going to add one called no test, KNOWTEST_pass. And then instead of cog_ab_sum, we're going to replace that with the variable we just created above there, which is no test_sum, paste it there. And then lastly, remember that cognitive ability cutoff score? Well, we're going to replace this with the knowledge test cutoff score, which is up here. So I'm going to copy that. This is the object we created that contains the cutoff score for the knowledge test. I'm going to paste it there. And so it's going to be the same thing. Here's our logical expression. If the knowledge test sum score for a person is greater than or equal to the cutoff, then they pass, which is the second argument. If else, they're going to fail. Okay? So let's go ahead and run that line. Take a peek at our data frame object, and you'll see now we have the knowledge test pass-fail scores as a new column or variable for each of the applicants as well. So you can kind of skim across here and see how people did for both the selection tools, the cognitive ability test and the knowledge test here, and whether or not they exceeded that cutoff score, which again differentiates those who pass or they fail. All right, so the next thing that we're going to do is we are going to create a vector, or rather we're going to create a variable, I should say, containing overall pass-fail scores based on both selection tools, okay? Because we're going to consider this to be a example of a multiple cutoff scenario, okay? So we have multiple cutoffs here because we have a cognitive ability test with a pass-fail or a cutoff score, and we have the same thing with a knowledge test. So there are multiple cutoffs here for these selection tools, okay? And this is going to be non-compensatory, as the name implies at the beginning of the tutorial, because if someone fails the cognitive ability test, they cannot compensate by passing the knowledge test. In order to pass through this selection hurdle here, you have to receive scores of pass on both the cognitive ability test and the knowledge test. So this makes it non-compensatory in nature. Okay, so the way that we're going to do that is we are going to apply the if-else function again, add parentheses, and then we're going to give it a logical expression here. So the logical expression is going to be if the name of our second data frame, $, cognitive ability, pass, so if that variable we just created here, so cognitive ability pass, and then we have knowledge test pass here, if that is equal to pass, okay, and our knowledge test variable, knowledge test underscore pass, is also equal to pass. So let's do the name of the data frame object, $, and then knowledge test pass is equal to pass. So this is our logical expression here. So if someone passes the cognitive ability test and they pass the knowledge test, that is going to be, they're going to pass the entire selection hurdle here. If not, they're going to fail. So both of these logical expressions here need to be true, okay, in order to pass the whole selection hurdle that's part of this multiple cutoff scenario here. And so we're using the logical and here, okay? So then we're going to add the second argument in our if-else function here, which is going to be pass, okay? So again, this is going to be if this logical statement here is true for anybody, they're going to receive a score of pass. And if else, if they don't receive a score of pass, meaning that they failed either one of these or both of these tests, they're going to get a score of fail, okay? So watch what happens if we run this line as is. We get that vector of people who passed or failed. So these are our 20 people. And so let's add this using a left-handed arrow assignment operator here. Let's add this vector as a new variable to our data frame. And again, that data frame is df2. Let's use that $sign operator so we can attach a new variable. And let's call this new variable overall underscore pass. Okay, so overall, did they pass this multiple hurdle selection scenario here where we have multiple cutoffs? Okay, so let's go ahead and click run here. And we go to our data frame object here, take a look at it in the viewer, and we will see who has passed and who has failed here. Okay, so again, in order to get an overall pass, you have to pass both of these selection tools here. So you can see the second applicant passed the cognitive ability test and they passed the knowledge test here. And so they received an overall pass here, okay? But you can see, let's see if we can find an example of someone, here's someone who failed the cognitive ability test, but passed the knowledge test, but they failed overall because this is a non-compensatory system. You have to pass all the cutoffs in order to make it through this selection hurdle. Whether that means the end of the hurdle is that you receive a job offer, or it means you're passed to another hurdle within a multiple hurdle system, for example. Okay, so the last thing that we're going to do is going to be creating a vector of the applicant IDs for those who passed and NAs or missing values for those who failed the multiple cutoff selection process, okay? And so we're gonna use that if-else function one more time here, and then our logical expression here, logical statement, is going to be the name of our data frame, df2, which is that second one that has the applicant data, our new variable, which is that overall underscore pass, okay? And then we are going to specify that if that is equal to, so we're using that equal operator there, so that just stands for equal to. If it is equal to pass, okay, which is what we specified here above for this variable, it's going to either have a pass or a fail here. Then our second argument is what happens if that statement is true. Well, if that's true, we're going to insert the name of our data frame object $, and then the applicant underscore ID variable. Okay, so we're going to insert the name of their unique identifier there, which is applicant underscore ID with a capital A and a capital I and D at the end, okay? Now, comma, and if this logical statement in the first argument is false, then for the third argument, we're going to specify the else in the if-else function, and that is it's going to be an NA or missing value. So watch what happens if we run this as is. Okay, so you'll see just a vector, and then it's all NAs or missing values except for AA2, AA10, AA13. These are the people who passed overall. They passed both the knowledge test and the cognitive ability test, so they've met this multiple cutoff scenario here as part of this selection process. So now let's use the left-handed arrow assignment operator, and let's create a new object that we'll call applicant underscore ID underscore pass. So this is the applicant ID if someone passed. This is just going to be a vector. We're not going to attach this to our data frame, although we could if we wanted, and I'll show you how you can do that in a second. And so if we do this and click run, we'll now have an object called applicant underscore ID pass that contains that vector. If we wanted to add this to the existing data frame, we could do this, df $, and then run this again. So df, I should say df2, that's the name of that second data frame, $, in the name of this vector here, this object. Click run, and then this would get appended to our existing data frame here. And you can see now we have those NAs, those missing values, and the only people that have their applicant IDs present there are those who actually pass both of the selection tests there, both of the selection tools, okay? I'm gonna remove that though, because what we're gonna do next, and as the final step, is we're going to retain only the applicant IDs for those who passed the multiple cutoff selection process, okay? And so what we're gonna do is specify the name of that object we just created, which is applicant underscore ID underscore pass. We're gonna type in square brackets, and then we are going to type in is.na, which is a function. So is a value an NA? Is it missing, in other words? So we saw here, again, NA represents missing values here in R. So is it NA? And then we're going to type in the name of that object from above that has that vector of whether someone passed. If else, it's just NA, it's missing, okay? And so if we do this as is, watch what happens. If we run this as is, it's going to give us all NAs, okay? Because it's just saying if there's an NA, print that. Otherwise, for those people who did pass, it leaves them out of this. Now, if we want to flip that function, we can put a not in front of it, which is an exclamation point here. So if it is not NA, we're going to return those people who passed, those unique identifiers, those applicant IDs for those people who passed here, okay? So let's highlight this and click run now that we've adapted that. And now we've printed out just the 3 unique applicant identifiers for those people who passed this multiple cutoff selection process here. And again, because this is part of a non-compensatory approach, these people pass because they passed both selection tools as part of this hurdle. If they had failed one of them, they would have not passed along. So these are the only 3 people who exceeded the cutoff score on both of the selection tools, and thus passed this multiple cutoff selection process as part of this hurdle. And again, if this is part of a multiple hurdle system where there's subsequent hurdles in this selection or hiring process, these are going to be the 3 people that you pass along. If this is the final hurdle, this means that these are probably the 3 people you're going to extend a job offer to. So this wraps up the tutorial on how you apply a non-compensatory approach to selection decisions using the Angoff method to create cutoff scores.